Okay, so for lesson 4.2, we're talking about functions and relations, and the goal of this lesson is for you to understand what domain, range, and functions are and be able to find them and determine them. So I'm going to go through this first page kind of quick because we already talked about them in class. So a relation is a set of ordered pairs. They can have one ordered pair, could have 10 ordered pairs, but when you put them together in the curly brackets, this is now a relation. It's a set of ordered pairs. Remember that the domain is a set of all of the x values, and the range is a set of all of the y values, and you always arrange these in order from least to greatest. If a number repeats, you only list it once. So looking at this example, we already talked about this in class. If you missed class about this, or if you are watching the video because you don't understand, you might need to ask questions about this because I'm going to move forward. But you have seen tables and you have seen graphs. The mapping is really the only thing that's new. In a mapping, you always list the domain values in the left circle. You list the range values in the right circle. And the arrows are to signify which is paired with which. So it shows you the ordered pairs. Again, remember that the domain is all of the x values and the range is all of the y values. We typically list them in order from least to greatest. You could list them from greatest to least, but normally I will list them from least to greatest. And if a number repeats, you only state it once. So picking up with example 2, if I look at A, my domain and range are continuous here. The graph is always connected. I'm talking about the domain, I'm looking at the x values. And the leftmost point for this graph starts at 0. And there's a point everywhere on this graph all the way up to x being 4. So I need to find a way to say that my range, my domain, all of my x values can be any number, including decimals, between 0 and 4. Even at like 2.1, there's a point on this graph. Even at 0.555, there would be a point on this graph. So we would use a compound inequality. We would say that x is greater than or equal to 0, and at the same time, it's less than or equal to 4. If you're using an inequality to state the domain, you do not need the curly brackets. Let's look at the range now. The range will be all of the possible y values. So if I'm looking for the range, I'm looking up on my y-axis. The lowest y value I have is 0 again, and there's a point on this graph everywhere in between 0 and 4, so I need to state that this goes from 0 to 4 with everything in between. Y is greater than or equal to 0, and at the same time, y is less than or equal to 4. So this is a continuous graph. If it is continuous, it will have a compound inequality, domain and range. Because it's an inequality, you do not need the curly brackets. We'll come back to this idea about a function. We have not defined a function yet, so we need to do that first. Let's look at B. B is a mapping. If I look at the mapping, I could determine my domain. Remember that the domain is always coming from this first bubble. So the domain would be the set of 8 and 9. All of my ordered pairs in this relation, if I were to list them out, the x values are 8 and 9. Okay, and I don't have to list them out, but I could. This is coming from 8, comma, -3. We would also have the ordered pair 8, -4. We would also have the ordered pair 8, -9. In addition to that, we would have 9 paired with -3, and we would have 9 paired with -6. So there's the relation, but you don't have to list those out. However, if by listing them, it might help you to make you understand it a little bit more. Your domain only includes 8 and 9. Those are the only two numbers that x are. For my range, all of the range values are really just the second circle. So you can look at the ordered pairs, but these are all your ranges, and those are going to go down here. Remember, we do list them as a set, and we typically put them in order from least to greatest. So I'm going to put -9, then -8, then -6. And I'm going to go that way, but you technically could do it the other way as well. I just like to always be consistent and do least to greatest. Again, we'll come back to this idea of if it's a function. Let's look at the third example. Determining the domain and the range from a table, just remember what domain and range mean. Domain is all of the x values in order from least to greatest. So 0, 1, 2. You don't have to show that 2 occurs twice and that 1 occurs twice. You only list it once. The range is all of the y values in order from least to greatest. So it'd be 4, 5, 6, 7, 8. Okay, so if we want to determine if this is a function, here's the definition of what a function is. A function means that each domain, each x, is paired to exactly one range. And the best way I can describe this is you're looking for the fact of thinking about a function as like a machine. So a function is like a machine. It takes something, you put it in, and you get an answer out. An example of a function would be like 2x plus 1, okay? So if I put in 5, 5 times 2 is 10, 10 plus 1 is 11, I would get out 11. The domain of x, being 5, would give me a range of y, being 11. I could put in a different domain. I could put in 1. 1 times 2 is 2. 2 plus 1 is 3. I could get an output of 3. And I could do this with tons of points. This is a function because every time I put in 5, I will always get out 11. There will never be a time where I put in 5 and I get a different answer, right? So this would be a function because each x value would be paired to one y value, okay? Another shortcut thing to think about is the fact that x can't repeat with different y values, okay? X really can't repeat, or if it does repeat, it always has to have the same y, all right? So let's look back at these three. If I look at this and I think about my input, when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. All of these are unique points. X is never paired with more than one y value. So is this a function? I would say yes. Every x has exactly one y. Okay, if we look at the next one, does each x value have exactly one y value? Well, when we look at it, when x is 8, oh, look, guys, this doesn't pass. When x is 8, it has a y of -3 sometimes. Other times it has a y of -4, and other times it has a y of -9. Well, if we look at the ordered pairs, x repeats, and it repeats with different y values. If x repeats and the y is not always the same, this is not a function. So I would say no. When x is 8, it is paired with more than one y value. Okay, or you could say, no, each x is not paired with exactly one y. But I like to point out the fact that, look, 8 is a problem of the example of the problem because 8 is paired with more than one y value. All right, the last one then, looking at this table, again, you look for those x values, guys. Specifically, look at x. Does x repeat? And if it does, is it with a different y value? So look, x is 1 twice. If I put 1 into my function machine, sometimes I get out 8 or 4, and other times I get out 7. That would not be a function because every time I put in 1, I should get out the same number. So is this a function? No. 1 in the domain, this is just another way of explaining it, is paired to 2 values in the range. Just a little note too, you can actually check to see this via here. The fact that there are fewer numbers in the domain and more numbers in the range means that one of these has to go to like two of those. We don't know which one it is, but we can tell that since there are fewer numbers in the domain than are in the range, you know one of them, maybe two of them, have to repeat. All right, so we will practice identifying functions, but it is important for you to understand what a function is. You need to know this definition. Each x value is paired to exactly one y value. So the vertical line test is the last part of this lesson then, and when you're doing the vertical line test, you want to draw vertical lines across your graph, and if any line hits your graph more than once, the graph is not a function. So for instance, if I look at this example, if I were to draw you kind of can't see it, so I'm going to darken it a little bit. Here's the graph. It looks like a curve that goes up and down. If you were to draw in a vertical line anywhere, does it ever hit more than once? So there it just hits once. Okay, then it would be a function. So even if I draw another line in, on the second line it only hits once. And as I move this line across the graph, if it ever hits more than once, it is not a function. Is this one a function? Yes. Why? Because it passes the vertical line test. When you draw any vertical line, no matter where you are, it will only cross the graph once. If we look at this next graph, again, I'm going to darken it. It looks like a curve. It's kind of sideways. If I draw in a vertical line anywhere on this graph, if it touches more than once, it is not a function. Look, guys, right here. If I draw in a vertical line, it's going to touch twice. So it fails the vertical line test. Is this a function? We would say no, this is not a function. If I asked you why, you would say it does not pass the vertical line test. Okay, so it only has to fail in one part for it to not be a function. So let's look at example 3. Give the domain and the range and tell whether it's a function and explain. Okay, well, example 3, A is a continuous graph. When you're talking about the domain, you're looking at the x values. So the x-axis is this one. The leftmost point, -4, and the rightmost point, 4, and it could be anywhere in between because there's a point up here that's 0. When x is 1, there's a point. When x is 2, there's a point. So my domain would be x is less than or equal to 4 and greater than or equal to -4. Excuse me, not 0 this time. When I do the range, now I'm looking at the y-axis. The y-axis, the highest point is 4. The lowest point of my graph is -4. So we just happen to have them be the same, but they will not always be the same here. We can see that y is greater than or equal to -4 and less than or equal to 4. Is this a function? When you draw a vertical line, does it ever cross more than once? Then it is not a function. So no, I would say it fails the vertical line test. The vertical line test is also really saying that each x is not paired to exactly one y. Okay? If we look at B, again, what is your domain? Look at the x values. Least to greatest, I would have 2, 3, and 4. Range would be this one. I would have -5, -4, -3. Is this a function? Is each x paired to exactly one y? Well, when I look at this, the x of 2 actually is paired with 2 different numbers. So this is not a function. Why? Each x is not paired to exactly one y value. You could also say each domain is not paired to exactly one range value.